Question 1. What factors determine the permissible operational scope and passenger carriage for a sport pilot certificate holder when operating a light sport aircraft? Option A. The pilot's personal comfort level with flying at higher altitudes and in low light conditions. Option B. The specific limitations and privileges outlined in the Federal Aviation Regulations, FAR, for sport pilots, including aircraft category, altitude, and time of day restrictions. Option C. The pilot's general knowledge of aviation and experience flying other types of aircraft. Option D. The maximum passenger capacity listed on the aircraft's registration. Correct answer is B. The specific limitations and privileges outlined in the Federal Aviation Regulations, FAR, for sport pilots, including aircraft category, altitude, and time of day restrictions. Explanation. This scenario is professionally challenging because it requires a pilot to accurately assess their own privileges and limitations as a sport pilot, balancing the desire to expand their flying activities with strict adherence to regulatory boundaries. Misinterpreting these boundaries can lead to unintentional violations, jeopardizing safety, and potentially leading to enforcement actions. Careful judgment is required to ensure all operations are conducted within the scope of the sport pilot certificate. The correct approach involves a thorough understanding of the specific limitations and privileges associated with a sport pilot certificate as defined by the Federal Aviation Regulations, FAR. This includes recognizing that a sport pilot is restricted to operating light sport aircraft, LSA, and is prohibited from carrying passengers at night or above 10,000 feet mean sea level, MSL, unless specific endorsements are obtained. The correct approach prioritizes safety and regulatory compliance by ensuring that any flight activity strictly adheres to these defined parameters. This aligns with the ethical responsibility of a pilot to operate their aircraft safely and legally, upholding the integrity of the aviation system. An incorrect approach would be to assume that because an aircraft is capable of higher altitudes or night flight, a sport pilot is permitted to operate it in those conditions without the necessary endorsements. This demonstrates a failure to consult and understand the specific limitations outlined in FAR 61-315. Another incorrect approach is to rely on the advice of a non-aviation professional or to make assumptions based on general aviation knowledge without verifying against the specific regulations for sport pilots. This disregards the principle of due diligence and the pilot's ultimate responsibility for understanding and complying with all applicable regulations. A further incorrect approach is to interpret the privileges broadly, believing that any aircraft that meets the definition of LSA can be operated without considering specific operational limitations like passenger carriage at night or altitude restrictions. This shows a lack of attention to the detailed operational restrictions that are critical for safe and legal sport pilot operations. Professional reasoning in such situations involves a systematic process. First, clearly identify the aircraft and the intended operation. Second, consult the relevant Federal Aviation Regulations, FAR, specifically Part 61, to understand the privileges and limitations of the pilot certificate being used. Third, cross-reference the aircraft's capabilities and the intended flight profile with these regulations. If there is any ambiguity or if the intended operation exceeds the defined privileges, seek clarification from official sources, such as the FAA or a certified flight instructor specializing in sport pilot training. Prioritize safety and compliance above all else. Question 2. Examination of the data shows that during the pre-flight inspection of your sport pilot airplane, the landing gear indicator light for the nose gear remains illuminated after the engine has been started and the propeller has begun to turn, contrary to the expected behavior where it should extinguish. What is the most appropriate course of action? Option A. Delay the flight and immediately contact a mechanic for a thorough inspection without consulting the POH first. Option B. Consult the aircraft's pilot's operating handbook PO for procedures related to landing gear indications and follow its guidance before flight. Option C. Proceed with the flight as planned, assuming the indicator light is malfunctioning, as the landing gear appears to be down visually. Option D. Attempt to cycle the landing gear manually to see if the light resets before deciding whether to fly. The correct answer is B. Consult the aircraft's pilot's operating handbook PO for procedures related to landing gear indications and follow its guidance before flight. Explanation. This scenario presents a professionally challenging situation because it requires the pilot to make a critical decision regarding the airworthiness of their aircraft based on an unusual landing gear indication. The challenge lies in balancing the immediate need to land with the paramount responsibility of ensuring safety, which is governed by strict regulatory adherence. The pilot must interpret the available information, understand the implications of potential landing gear malfunctions, and act in accordance with established aviation regulations. The correct approach involves a thorough pre-flight inspection and a systematic troubleshooting process upon encountering the abnormal indication. This includes consulting the aircraft's pilot's operating handbook (PO) for specific procedures related to landing gear anomalies. The POH provides manufacturer-approved checklists and guidance for dealing with such issues, ensuring the pilot follows a safe and standardized protocol. This approach is correct because it directly aligns with the regulatory framework for operating an aircraft, which mandates that pilots ensure the aircraft is in an airworthy condition before flight and to follow approved procedures when encountering malfunctions. Specifically, 14 CFR 91(7)(a) states that no person may operate an aircraft unless it is in an airworthy condition, and 14 CFR 91(213)(a) requires that a pilot in command shall not operate an aircraft if any instrument or equipment necessary for the safe operation of that aircraft is not functioning properly. Consulting the POH is the primary method for determining the airworthiness of the aircraft and the appropriate course of action. An incorrect approach would be to ignore the indication and proceed with a normal landing. This is professionally unacceptable because it directly violates the principle of ensuring airworthiness and disregards potential safety hazards. It fails to comply with 14 CFR 91(7)(a) and 14 CFR 91(213)(a) by operating an aircraft with a known or suspected malfunction that could compromise safe operation. Another incorrect approach would be to attempt a landing without consulting the POH or seeking expert advice. This is professionally unsound as it relies on guesswork rather than established procedures. Aviation safety relies on standardized protocols and expert knowledge, not on ad hoc decision-making in critical situations. This approach fails to meet the standard of care expected of a pilot and could lead to a dangerous outcome, potentially violating 14 CFR 91(13)(a) regarding careless or reckless operation. A further incorrect approach would be to assume the indication is a false warning and proceed as if everything is normal, without any verification. This is a dangerous assumption that bypasses the critical safety checks mandated by regulations. The purpose of such indications is to alert the pilot to a potential problem, and ignoring them without proper investigation is a direct contravention of the safety-first principle inherent in aviation regulations. The professional decision-making process for similar situations involves a structured approach. 1. Recognize the abnormal indication. 2. Immediately consult the aircraft's POH for relevant emergency or abnormal procedures. 3. If the POH provides a clear course of action that ensures safety, follow it. 4. If the POH is unclear or the situation remains uncertain, prioritize safety by seeking assistance from qualified maintenance personnel or air traffic control, and consider diverting to the nearest suitable airport for inspection. 5. Never compromise safety by operating an aircraft with a known or suspected airworthiness issue without proper resolution. Question 3. When evaluating the instruments in a sport pilot airplane during straight and level flight, you observe that the heading indicator shows a heading of 270 degrees, but the magnetic compass indicates 285 degrees. Which approach best reflects the proper procedure for determining your actual magnetic heading? Option A. Trust the magnetic compass as the primary source of accurate heading information in straight and level, an accelerated flight, and use this to correct the heading indicator. Option B. Assume the magnetic compass is malfunctioning due to its deviation and variation errors, and continue to fly the heading indicated by the heading indicator. Option C. Rely on the heading indicator because it is a more stable instrument and less prone to fluctuations than the magnetic compass. Option D. Immediately initiate a turn to realign the heading indicator with the magnetic compass, as this will resolve any discrepancies. The correct answer is A. Trust the magnetic compass as the primary source of accurate heading information in straight and level, unaccelerated flight, and use this to correct the heading indicator. Explanation. This scenario is professionally challenging because it requires a sport pilot to make a critical judgment call regarding instrument functionality in a real-world flight situation, directly impacting safety. The sport pilot must reconcile potentially conflicting information from two primary heading instruments, the heading indicator and the magnetic compass, while adhering to strict aviation regulations. The challenge lies in understanding the inherent limitations and operational characteristics of each instrument, and applying that knowledge to ensure accurate situational awareness. The correct approach involves understanding that the heading indicator is a gyroscopic instrument susceptible to precession and erection errors, especially during turns or accelerations, while the magnetic compass is subject to magnetic dip and variation errors. A sport pilot must recognize that in straight and level, unaccelerated flight, the magnetic compass is the primary source of true heading information, albeit with its own inherent inaccuracies. The heading indicator, when properly aligned and functioning, provides a more stable and easily readable indication of heading, but it must be periodically checked against the magnetic compass. Therefore, the correct approach is to trust the magnetic compass for accurate heading information during straight and level flight, while acknowledging the heading indicator's role as a supplementary, more stable display that requires periodic correction. This aligns with the fundamental principles of instrument cross-checking and reliance on the most accurate available information for the given flight condition, as implicitly required by safe operating practices and the spirit of regulatory compliance for maintaining situational awareness. An incorrect approach would be to solely rely on the heading indicator without cross-checking it against the magnetic compass. This fails to account for the heading indicator's susceptibility to errors like precession, which can lead to a significant divergence from the actual magnetic heading over time, especially after prolonged turns or maneuvers. This disregard for cross-checking violates the principle of instrument redundancy and verification, a cornerstone of safe aviation practice. Another incorrect approach would be to dismiss the magnetic compass entirely and assume the heading indicator is always accurate. This ignores the fundamental limitations of gyroscopic instruments and the fact that the magnetic compass, despite its own errors, is the direct reference to magnetic north. Relying solely on a potentially drifting heading indicator without verification is a direct contravention of safe operating procedures and could lead to significant navigational errors. A further incorrect approach would be to prioritize the visual appearance of stability from the heading indicator over the accuracy of the magnetic compass. While the heading indicator may appear more steady, its stability does not equate to accuracy if it has precessed. Prioritizing perceived stability over actual heading information is a dangerous misjudgment that compromises the pilot's ability to maintain the intended course. The professional decision-making process for similar situations involves a systematic approach to instrument interpretation. Pilots should first understand the operational principles and limitations of each instrument. During flight, they must engage in regular instrument cross-checking, comparing indications from multiple instruments to identify discrepancies. When discrepancies arise, the pilot must determine which instrument is providing the most reliable information for the current flight condition, e.g., straight and level, turning, accelerating. This involves applying knowledge of instrument errors and prioritizing the instrument that is least affected by the current flight dynamics or has a direct reference to the desired navigational parameter. Ultimately, safety and adherence to regulatory intent for accurate navigation are paramount. Question 4. Process analysis reveals that a sport pilot airplane is climbing out after takeoff into a moderate tailwind with flaps partially extended for a slower approach speed. The pilot needs to maintain a safe climb rate and airspeed. Which of the following best describes the pilot's primary consideration regarding the forces acting on the aircraft in this situation? Option A. The tailwind primarily affects ground speed, so the pilot can maintain a slightly lower airspeed than usual without compromising the climb performance. Option B. The pilot should focus on maintaining a constant pitch attitude, as this will automatically ensure the correct balance of forces for a safe climb. Option C. The pilot must ensure that thrust is sufficient to overcome the increased drag from the partially extended flaps and the tailwind's effect on airspeed, while lift must remain adequate to counteract weight at the target climb airspeed. Option D. The pilot should retract the flaps immediately to reduce drag and maximize the climb rate, as the tailwind will already be assisting the climb. The correct answer is C. The pilot must ensure that thrust is sufficient to overcome the increased drag from the partially extended flaps and the tailwind's effect on airspeed, while lift must remain adequate to counteract weight at the target climb airspeed. Explanation: this scenario presents a professional challenge because it requires a sport pilot airplane pilot who apply their understanding of fundamental aerodynamic forces in a practical, risk assessment context. The challenge lies in accurately identifying how changes in aircraft configuration and environmental conditions affect the balance of lift, weight, thrust, and drag, and then making appropriate decisions to maintain safe flight. Careful judgment is required to anticipate and mitigate potential hazards arising from an imbalance of these forces. The correct approach involves recognizing that during a climb after takeoff, thrust must exceed the sum of drag and the component of weight acting parallel to the flight path to gain altitude. Lift must be sufficient to counteract weight, and this is achieved by maintaining an appropriate airspeed. Understanding that extending flaps increases drag and can also affect lift, and that tailwind reduces ground speed but not airspeed, is crucial. Therefore, pilot must adjust their control inputs to maintain the correct airspeed and climb rate, ensuring that the forces are balanced for a safe ascent. This aligns with the fundamental principles of aerodynamics and safe flight operations as expected of a sport pilot, emphasizing proactive control and understanding of aircraft performance. An incorrect approach would be to assume that the tailwind only affects ground speed and has no bearing on the forces acting on the aircraft in flight. This fails to recognize that, while airspeed is the critical factor for lift and drag, the pilot's perception of performance, e.g., climb rate relative to the ground, can be influenced by ground speed, and the pilot must still maintain the correct airspeed for aerodynamic efficiency and safety. Another incorrect approach would be to ignore the increased drag from extended flaps, leading to a potential loss of airspeed and climb performance. This demonstrates a failure to account for all contributing forces. A third incorrect approach would be to focus solely on maintaining a specific pitch attitude without considering the resulting airspeed and the balance of forces, which could lead to a stall if airspeed decays too much. These incorrect approaches demonstrate a lack of comprehensive understanding of how multiple factors interact to affect aircraft performance and safety. Professionals should use a decision-making framework that involves 1. Situational awareness, continuously assessing all relevant factors, including aircraft configuration, environmental conditions, and performance. 2. Knowledge application, applying fundamental aerodynamic principles to understand how these factors influence the forces acting on the aircraft. 3. Risk assessment, identifying potential hazards arising from an imbalance of forces and evaluating their severity. 4. Proactive control, making timely and appropriate control inputs to maintain the desired flight path and ensure the forces remain balanced for safe operation. Question 5. The risk matrix shows a potential discrepancy in the airspeed indicator reading during a climb, suggesting a possible deviation from expected performance. Considering the sport pilot airplane curriculum, which of the following diagnostic considerations best addresses the potential causes of this reading? Option A. The pilot should assume the discrepancy is a minor calibration issue and continue the flight as planned. Option B. The pilot should primarily consider if the pitot tube is experiencing icing, as this directly impacts the airspeed indication. Option C. The pilot should focus solely on the altimeter reading, as it is directly linked to airspeed in a climb. Option D. The pilot should evaluate whether the discrepancy is due to the physical placement and mounting of the airspeed indicator itself, or an inherent flaw within the instrument's mechanism. The correct answer is B. The pilot should primarily consider if the pitot tube is experiencing icing, as this directly impacts the airspeed indication. Explanation: this scenario is professionally challenging because it requires a sport pilot airplane pilot to discern the root cause of a potentially critical instrument discrepancy under pressure, directly impacting flight safety. The pilot must not only recognize a deviation, but also understand its potential origins and the implications for accurate flight control. This demands a thorough understanding of aircraft systems and instrument limitations, as outlined in the FAA's Sport Pilot Airplane Airman Certification Standards (ACS) and the Pilot's Handbook of Aeronautical Knowledge (FAC). The correct approach involves a systematic evaluation of potential system errors, specifically differentiating between position error and instrument error. Position error arises from the physical location and mounting of an instrument, affecting the air pressure it senses, while instrument error is an inherent inaccuracy within the instrument itself. A pilot employing this approach would consider how airspeed indicator readings might be affected by factors like pitot tube icing, a form of instrument error affecting the sensor, or a blocked static port, a form of position error affecting the pressure input. This methodical consideration aligns with the FAA's emphasis on risk management and decision-making, requiring pilots to identify and mitigate hazards by understanding the underlying causes of instrument malfunctions. The regulatory framework, particularly FAR 61, 31D, regarding pilot responsibilities, and the ACS's emphasis on aeronautical knowledge and risk management, mandates this level of understanding. An incorrect approach would be to solely attribute the discrepancy to a single, unverified cause, without considering other possibilities. For instance, assuming the airspeed indicator is simply malfunctioning without investigating potential external factors like pitot static system issues would be a failure to conduct a comprehensive diagnostic. This bypasses the critical step of identifying the specific type of error, position VS, instrument, and its potential impact on other instruments. Another incorrect approach would be to disregard the discrepancy entirely, believing it to be minor, which directly violates the pilot's responsibility to ensure the airworthiness of the aircraft and the accuracy of its instruments before and during flight, as stipulated in FAR 91, 7 and FAR 91, 213. This demonstrates a lack of diligence and an unacceptable level of risk acceptance. Professional decision-making in such situations requires a structured approach. First, recognize the anomaly. Second, consult available resources, e.g., aircraft checklist PO. Third, systematically hypothesize potential causes, considering both instrument and position errors. Fourth, take appropriate action based on the most probable cause and its safety implications, which may include diverting or landing. Question 6. Regulatory review indicates that sport pilot airplane pilots are responsible for ensuring the airworthiness of their aircraft. Considering the electrical system, what is the most appropriate pilot action when the voltage indicator shows a consistently low reading and the amperage indicator fluctuates erratically during pre-flight and initial climb? Option A. Continue the flight as planned, assuming the readings are within an acceptable tolerance for this phase of flight. Option B. Immediately land the aircraft at the nearest suitable airport and seek maintenance assistance. Option C. Attempt to troubleshoot the electrical system by cycling various electrical components on and off. Option D. Note the readings in the aircraft logbook and proceed with the flight, planning to have it inspected upon return. Correct answer is A. Continue the flight as planned, assuming the readings are within an acceptable tolerance for this phase of flight. Explanation. This scenario presents a professional challenge for a sport pilot airplane pilot because it requires them to interpret and apply specific regulatory requirements concerning aircraft electrical systems, particularly the function and importance of voltage and amperage indicators. The challenge lies in understanding the practical implications of these instruments for safe flight operations, and knowing when their proper functioning is critical, as mandated by regulations. Careful judgment is required to differentiate between minor anomalies and conditions that could compromise flight safety or airworthiness. The correct approach involves recognizing that the voltage and amperage indicators are essential for monitoring the aircraft's electrical system health. A pilot must understand that these instruments provide vital information about the battery's charging status and the overall electrical load. If the indicators show abnormal readings, such as consistently low voltage or excessive amperage draw, it signals a potential problem that could lead to electrical system failure, impacting essential equipment like radios, navigation systems, and flight instruments. The regulatory framework for sport pilot airplane operations, specifically concerning aircraft maintenance and pilot responsibilities, mandates that pilots ensure their aircraft is in an airworthy condition before flight. This includes verifying the proper functioning of all essential instruments. Therefore, a pilot must take appropriate action, which may include consulting the aircraft's maintenance records, seeking professional maintenance advice, or grounding the aircraft until the issue is resolved, to comply with the overarching requirement of operating a safe and airworthy aircraft. An incorrect approach would be to disregard or minimize the significance of abnormal readings on the voltage and amperage indicators. For instance, assuming that a slightly low voltage reading is acceptable without further investigation, fails to acknowledge the potential for a cascading electrical failure. This neglects the pilot's responsibility to ensure the aircraft is airworthy, as required by regulations. Another incorrect approach would be to continue flight operations with a known electrical system anomaly without understanding its full implications. This directly violates the principle of operating a safe aircraft and could lead to a critical loss of electrical power in flight, jeopardizing the safety of the pilot and any passengers. Furthermore, attempting to diagnose or repair complex electrical issues without proper training or authorization is also an unacceptable approach, as it falls outside the scope of a pilot's responsibilities and could exacerbate the problem or create new safety hazards. The professional decision-making process for similar situations should begin with a thorough understanding of the aircraft systems and the function of each instrument. Pilots should be familiar with the normal operating ranges for their aircraft's electrical instruments as outlined in the Aircraft's Pilot's Operating Handbook, POH, or Aircraft Maintenance Manual. Upon observing any deviation from normal, the pilot should first consult the POH for guidance on interpreting such readings and recommended actions. If the POH does not provide sufficient clarity, or if the anomaly appears significant, the pilot should then consider the potential impact on flight safety and the aircraft's airworthiness. This may involve consulting with a qualified mechanic or maintenance personnel. The ultimate decision should always prioritize safety and regulatory compliance, which may mean delaying or canceling a flight until the issue is satisfactorily resolved. Question 7. Process analysis reveals that a sport pilot airplane pilot, while en route to their destination, notices a significant and unusual fluctuation in the aircraft's electrical system voltage, accompanied by intermittent dimming of cockpit instruments. The pilot has a basic understanding of electrical systems as part of their training, but is not a certified mechanic. What is the most appropriate immediate course of action according to the regulatory framework for sport pilots? Option A. Immediately initiate procedures to land the aircraft at the nearest suitable airport, consulting the aircraft's pilot's operating handbook, POH, for relevant emergency procedures. Option B. Continue to the original destination, assuming the electrical fluctuation is minor and will likely resolve itself before landing. Option C. Attempt to troubleshoot and repair the electrical issue in flight by manipulating various circuit breakers and switches based on general knowledge. Option D. Reduce power to conserve electrical energy and hope the system stabilizes on its own. Correct answer is A. Immediately initiate procedures to land the aircraft at the nearest suitable airport, consulting the aircraft's pilot's operating handbook, POH, for relevant emergency procedures. Explanation. Scenario analysis. This scenario presents a professional challenge because a sport pilot airplane pilot encounters an unexpected electrical system issue during flight. The pilot must make a critical decision under pressure, balancing safety, aircraft airworthiness, and regulatory compliance. The challenge lies in accurately assessing the severity of the electrical anomaly, understanding the limitations of their pilot certificate, and knowing when to seek expert assistance versus attempting a temporary fix. Misjudgment could lead to a loss of control, an unsafe landing, or a violation of regulations. Correct approach analysis. The correct approach involves immediately prioritizing safety by initiating procedures to land the aircraft as soon as practicable in a safe location. This aligns with the fundamental principle of aviation safety, which dictates that the pilot in command has the ultimate responsibility for the safe operation of the aircraft. Specifically, for a sport pilot airplane, the pilot is trained to handle certain emergencies, but is also aware of their limitations. The correct action is to consult the aircraft's pilot's operating handbook, POH, for emergency procedures related to electrical system malfunctions and to prepare for a precautionary landing. This adheres to the spirit and letter of FAA regulations, 14 CFR Part 61 and Part 91, which emphasize pilot responsibility for safe flight and the requirement to operate aircraft in an airworthy condition. The POH provides specific guidance for the aircraft type, ensuring the pilot follows manufacturer-recommended procedures. Incorrect approach is analysis. Continuing the flight to the original destination without landing, despite a significant electrical system anomaly, is an incorrect approach. This disregards the potential for the electrical issue to worsen, leading to a complete loss of essential systems, e.g., navigation, communication, or even engine control if electrically dependent. This action violates the implicit duty of care and the explicit regulatory requirement to maintain aircraft airworthiness and operate safely. Attempting a complex repair in flight without proper training or tools is also an incorrect approach. A sport pilot airplane certificate has limitations, and attempting repairs beyond the scope of basic troubleshooting or emergency procedures outlined in the POH is not authorized and is extremely dangerous. This could exacerbate the problem, create new hazards, and potentially lead to a catastrophic failure. It also bypasses the requirement for maintenance to be performed by qualified personnel. Ignoring the electrical issue and hoping it resolves itself is a fundamentally unsafe and incorrect approach. This demonstrates a failure to proactively manage risk and a disregard for the potential consequences of an electrical malfunction. Aviation safety relies on pilots actively identifying, assessing, and mitigating hazards, not passively hoping they disappear. Professional reasoning. Professionals in aviation must employ a systematic decision-making framework when faced with unexpected events. This framework typically involves 1. Aviate, maintain control of the aircraft. 2. Navigate, determine position and heading. 3. Communicate, inform relevant parties of the situation. 4. Identify the problem, understand the nature and severity of the anomaly. 5. Consult resources, refer to the POH checklists or air traffic control for guidance. 6. Assess risk, evaluate the potential consequences of different actions. 7. Decide and act, choose the safest course of action and execute it decisively. For a sport pilot, airplane pilot facing an electrical issue, this framework prioritizes immediate safety through a precautionary landing, followed by proper diagnosis and repair by qualified personnel. Question 8. Operational review demonstrates that a sport pilot, airplane pilot is approaching a landing. The pilot has deployed the flaps to their recommended setting for landing. Considering the effects of flap deployment on aircraft performance, which of the following actions is most critical for maintaining safe and controlled flight during this phase? Option A. Increasing engine power to compensate for the increased drag created by the flaps. Option B. Retracting the flaps immediately to reduce the stall speed and improve maneuverability. Option C. Focusing solely on maintaining a constant airspeed without regard to pitch attitude or control forces. Option D. Adjusting the elevator trim to relieve control pressure and maintain the desired pitch attitude at the reduced airspeed. Correct answer is D. Adjusting the elevator trim to relieve control pressure and maintain the desired pitch attitude at the reduced airspeed. Explanation. This scenario is professionally challenging because it requires a sport pilot, airplane pilot to apply their understanding of secondary flight controls to a real-world operational decision, directly impacting safety and efficiency. The pilot must not only know what flaps and trim are, but also how their deployment and adjustment affect the aircraft's performance characteristics in a specific flight phase. Misunderstanding these effects can lead to improper aircraft handling, increased stall speeds, reduced maneuverability, and potentially unsafe situations, especially during critical phases like landing or takeoff. The correct approach involves understanding that extending flaps increases lift and drag, which is beneficial for shorter takeoff and landing distances, but also increases the aircraft's stall speed and requires a higher angle of attack for level flight at a given airspeed. Trim systems are used to relieve control pressure, allowing the pilot to maintain a desired attitude without constant control input. Properly adjusting trim in conjunction with flap deployment is crucial for maintaining stable flight and control authority. This approach aligns with the fundamental principles of aerodynamics and aircraft control taught in sport pilot airplane training, emphasizing safe and efficient operation. The FAA regulations, such as those found in 14 CFR Part 61, mandate that pilots understand aircraft performance and the effects of control inputs, including secondary controls, on that performance. An incorrect approach that focuses solely on the visual appearance of flap extension, without considering the aerodynamic consequences, fails to meet regulatory requirements for understanding aircraft performance. This oversight can lead to misjudging landing speeds or takeoff distances. Another incorrect approach that neglects the need for trim adjustment after flap deployment will result in increased control forces, pilot workload, and potentially unstable flight, which is contrary to the safe operation principles mandated by aviation authorities. Finally, an approach that assumes flaps only affect speed without considering their impact on lift and stall characteristics demonstrates a critical gap in aerodynamic knowledge, potentially leading to hazardous situations like premature stalls. Professional decision-making in such situations requires a systematic approach. First, assess the current flight phase and desired outcome, e.g., landing, takeoff. Second, recall the specific aerodynamic effects of deploying secondary controls like flaps, including their impact on lift, drag, and stall speed. Third, consider the necessary adjustments to primary controls and trim to maintain desired aircraft attitude and airspeed. Finally, continuously monitor aircraft performance and be prepared to make further adjustments as needed, always prioritizing safety and adherence to aircraft operating limitations and regulatory guidance. Question 9. Benchmark analysis indicates that a sport pilot operating a single-engine airplane encounters a situation where the tachometer reading fluctuates slightly below the normal range, while the oil pressure gauge shows a steady reading within the green arc, and the oil temperature gauge indicates a slightly elevated but stable temperature. Which of the following represents the most prudent and safety-conscious course of action? Option A. Continue the flight as planned, focusing solely on maintaining the steady oil pressure and temperature, as the tachometer fluctuation is likely insignificant. Option B. Immediately initiate a precautionary landing at the nearest suitable airport due to the tachometer fluctuation. Option C. Maintain current course and altitude, continue to monitor all engine instruments closely for any further changes, and consider troubleshooting if the tachometer deviation worsens or other instruments show concerning trends. Option D. Reduce engine power significantly to see if the tachometer reading stabilizes within the normal range. Correct answer is B. Immediately initiate a precautionary landing at the nearest suitable airport due to the tachometer fluctuation. Explanation. This scenario presents a professional challenge for a sport pilot because it requires them to interpret and act upon information from multiple engine instruments under potentially stressful conditions, such as during a flight. The challenge lies in understanding the normal operating ranges for each instrument and recognizing deviations that could indicate a developing problem, necessitating a timely and appropriate response. Careful judgment is required to differentiate between minor fluctuations and significant issues that could compromise flight safety. The correct approach involves a pilot systematically checking each engine instrument against its known normal operating parameters and considering the interrelationships between them. For example, a drop in oil pressure accompanied by a rise in oil temperature would be a more critical indicator than a slight fluctuation in tachometer reading alone. This systematic approach ensures that all relevant data is considered, leading to a more accurate assessment of the engine's condition. This aligns with the fundamental principle of aviation safety, which emphasizes thorough pre-flight and in-flight checks and a proactive approach to identifying and mitigating potential hazards. Specifically, regulations for sport pilots require them to be proficient in the operation of their aircraft, which includes understanding and monitoring engine instruments to ensure safe flight. Failure to do so could be considered a violation of the pilot's responsibility to operate the aircraft safely. An incorrect approach would be to focus solely on one instrument, such as the tachometer, and disregard readings from other instruments like the oil pressure or temperature gauges. This is a regulatory failure because it demonstrates a lack of comprehensive understanding of engine operation and monitoring, which is a required skill for all pilots. It also represents an ethical failure, as it prioritizes a single data point over a holistic assessment of engine health, potentially leading to a misdiagnosis of a critical issue. Another incorrect approach would be to assume that any deviation from the exact center of a gauge is an immediate emergency requiring immediate landing, without first considering the normal operating range or potential for minor fluctuations. This is a failure of professional judgment and demonstrates a lack of understanding of typical engine behavior. While vigilance is crucial, overreacting to minor variations can lead to unnecessary diversions and stress, potentially creating a more hazardous situation than the initial minor deviation. This approach fails to meet the standard of operating the aircraft with the care and judgment expected of a certificated pilot. A third incorrect approach would be to ignore an unusual reading on a critical instrument, such as a sudden drop in oil pressure, because the flight is nearing its destination. This is a severe regulatory and ethical failure. It directly contravenes the principle of maintaining aircraft safety throughout the entire flight, regardless of proximity to the destination. Ignoring such a critical warning sign demonstrates a disregard for the potential for catastrophic engine failure and puts the pilot, passengers, and people on the ground at significant risk. The professional decision-making process for similar situations involves a layered approach. First, understanding the normal operating parameters of all engine instruments. Second, developing a habit of regular scanning and monitoring of these instruments. Third, recognizing deviations from normal and understanding their potential implications. And fourth, taking appropriate action based on the severity of the deviation, which may range from continued monitoring to immediate troubleshooting or emergency landing. This process is grounded in regulatory requirements for pilot proficiency and the overarching ethical obligation to prioritize safety. Question 10. Research into the operational differences between fixed tricycle landing gear and conventional tailwheel configurations. A sport pilot applicant is offered the opportunity to fly a friend's aircraft, which is a tailwheel airplane. The applicant has extensive experience in fixed tricycle gear aircraft, but has never flown a tailwheel airplane and has not received any specific training for this configuration. The applicant is aware that their current sport pilot certificate is endorsed for airplane single-engine land, but does not have a specific tailwheel endorsement. The applicant considers flying the tailwheel airplane, rationalizing that the principles of flight are the same and they can quickly adapt given their overall flying experience. What is the most appropriate and legally compliant course of action for the sport pilot applicant in this situation? Option A. Attempt to fly the tailwheel airplane with a non-pilot friend who has some tailwheel experience as a passenger to provide guidance during the flight. Option B. Fly the tailwheel airplane in a very open and controlled environment, such as a large, empty parking lot, to practice the ground handling and takeoff before attempting a runway landing. Option C. Decline to fly the tailwheel airplane until they have received the appropriate training and endorsement from a certified flight instructor, CFI, specifically for tailwheel operations. Option D. Proceed with flying the tailwheel airplane, relying on their existing general aviation experience to adapt quickly to the new landing gear configuration. Correct answer is D. Proceed with flying the tailwheel airplane, relying on their existing general aviation experience to adapt quickly to the new landing gear configuration. Explanation. This scenario presents a professional challenge because it requires a pilot to balance personal convenience and perceived operational efficiency against strict adherence to regulatory requirements and the fundamental principles of aviation safety. The pilot's desire to use a familiar aircraft, even with a different landing gear configuration, introduces a conflict between personal preference and the need for proficiency and compliance. The correct approach involves the pilot recognizing their limitations and prioritizing safety and regulatory compliance above all else. This means acknowledging that operating an aircraft with a landing gear configuration they are not currently proficient in, or for which they do not hold the appropriate endorsement, is unsafe and illegal. The pilot must seek the necessary training and endorsement to operate the tailwheel aircraft safely and legally. This aligns with the fundamental principle of aviation safety, which mandates that pilots only operate aircraft for which they are qualified and endorsed. Specifically, under U.S. Federal Aviation Regulations, FAR, operating a tailwheel aircraft requires a specific endorsement if the pilot's existing certificate does not already permit it, and proficiency is paramount. The ethical obligation is to ensure the safety of oneself, passengers, and the public by operating within the bounds of one's training and certification. An incorrect approach would be to operate the tailwheel aircraft without the proper endorsement or sufficient recent practice. This is a direct violation of FARs, which stipulate the requirements for operating different aircraft types and configurations. Ethically, it demonstrates a disregard for the established safety protocols designed to prevent accidents. Another incorrect approach would be to rely solely on past experience with similar aircraft, assuming that prior knowledge is sufficient without formal training or endorsement. While experience is valuable, it does not replace the specific requirements for operating a particular aircraft configuration, especially one known for its unique handling characteristics like a tailwheel airplane. This approach fails to acknowledge the potential for subtle differences and the need for current, specific proficiency. The professional decision-making process in such situations should involve a clear assessment of personal qualifications against the requirements of the intended operation. This includes reviewing the aircraft's operating limitations, understanding the specific endorsements and ratings required, and honestly evaluating one's own proficiency. If there is any doubt or a lack of current qualification, the professional decision is to seek appropriate training and certification before undertaking the flight. This proactive approach ensures compliance, maintains safety standards, and upholds the integrity of the pilot's certification. Question 11. To address the challenge of an erratic fuel quantity indicator in a sport pilot airplane during cruise flight, Which of the following actions best reflects a safe and regulatory compliant response? Option A. Rely solely on the fuel selector position to determine the remaining fuel, as this is the primary control for fuel delivery. Option B. Immediately switch to the fullest tank indicated by the selector. Visually inspect the fuel tanks for any leaks or unusual conditions if possible, and monitor engine performance closely for any signs of fuel starvation. Option C. Land at the nearest suitable airport without further investigation, as any fuel system anomaly is a critical safety concern. Option D. Continue the flight as planned, assuming the indicator is malfunctioning and the actual fuel quantity is sufficient based on the last known fuel load. The correct answer is B. Immediately switch to the fullest tank indicated by the selector. Visually inspect the fuel tanks for any leaks or unusual conditions if possible, and monitor engine performance closely for any signs of fuel starvation. Explanation: this scenario is professionally challenging because it requires a pilot to make a critical judgment call regarding the aircraft's fuel system integrity based on potentially ambiguous indications. The sport pilot airplane pilot must prioritize safety above all else, adhering strictly to the aircraft's pilot's operating handbook (PO) and applicable federal aviation regulations (FAR). The challenge lies in interpreting the fuel quantity indicator's erratic behavior in conjunction with other sensory inputs and making a decision that ensures safe flight without unnecessary diversion or risk. The correct approach involves a systematic troubleshooting process that aligns with established aviation safety practices and regulatory guidance. This approach prioritizes verifying the fuel quantity through multiple means, including visual inspection of the fuel tanks if possible, and cross-referencing with the fuel selector position and engine performance. The regulatory framework, specifically 14 CFR Part 61, mandates that pilots operate aircraft safely and in accordance with their POH. The POH will contain specific procedures for handling fuel system anomalies. Therefore, consulting the POH and performing a thorough, multifaceted check is the most appropriate and safest course of action, directly addressing the potential for a fuel system malfunction. An incorrect approach would be to ignore the erratic fuel quantity indication and continue the flight as normal. This fails to acknowledge a potential safety of flight issue and directly violates the pilot's responsibility to ensure the aircraft is airworthy and operated safely. Relying solely on the fuel selector position without verifying the actual quantity in the tanks is also an unacceptable approach, as a faulty indicator could mask a genuine fuel shortage or an issue with fuel delivery. Another incorrect approach would be to immediately land at the nearest airport without attempting any troubleshooting. While landing is a safe option, an immediate, untroubleshot landing might be overly cautious and unnecessary, potentially leading to a diversion that could have been avoided with proper diagnosis, though safety remains paramount. However, the primary failure in this approach is the lack of systematic troubleshooting as outlined in the POH. The professional decision-making process for similar situations involves a structured approach: aviate, navigate, communicate. First, maintain control of the aircraft. Aviate. Then, assess the situation and determine the best course of action, which includes troubleshooting the fuel system anomaly. Navigate. Finally, if necessary, communicate the situation to air traffic control or other relevant parties. This process emphasizes a calm, methodical response to unexpected events, prioritizing safety and adherence to regulations and aircraft operating procedures. Question 12. Analysis of a sport pilot airplane climbing out after takeoff notices a gradual decrease in airspeed. The pilot's primary concern is to maintain sufficient lift to prevent a stall. Considering the fundamental principles of airfoil theory, what is the most accurate understanding of the pilot's required action regarding the angle of attack? Option A. The pilot must increase the angle of attack to compensate for the decreasing airspeed and maintain sufficient lift. Option B. The angle of attack is not a significant factor as long as the airspeed remains above the published stall speed. Option C. The pilot should maintain a constant angle of attack, as the decreasing airspeed will naturally increase lift. Option D. The pilot should decrease the angle of attack to reduce drag and allow airspeed to recover. The correct answer is A. The pilot must increase the angle of attack to compensate for the decreasing airspeed and maintain sufficient lift. Explanation: scenario analysis. This scenario presents a common challenge for sport pilots. Understanding the dynamic relationship between airspeed, angle of attack, and the resulting aerodynamic forces particularly as an aircraft approaches a stall. Challenge lies in recognizing the subtle cues and applying theoretical knowledge to maintain safe flight, especially during critical phases like takeoff or landing where margins for error are reduced. Misinterpreting these cues or misapplying the theory can lead to a loss of control. Correct approach analysis. The correct approach involves recognizing that as the pilot reduces airspeed during the climb-out, the wing's angle of attack must increase to maintain sufficient lift. This increase in angle of attack is a direct consequence of the fundamental relationship between airspeed and the angle of attack required to generate a specific amount of lift. As airspeed decreases, a higher angle of attack is needed to compensate and keep the lift generated equal to the aircraft's weight. This understanding is crucial for preventing the wing from exceeding its critical angle of attack, which would lead to a stall. The regulatory framework for sport pilots emphasizes a thorough understanding of aerodynamics to ensure safe operation, and this scenario directly tests that understanding. Incorrect approaches analysis. An incorrect approach would be to assume that reducing airspeed automatically means the angle of attack is also decreasing, or that the angle of attack is irrelevant as long as airspeed is above a certain minimum. This fundamentally misunderstands how lift is generated and maintained. Reducing airspeed without a corresponding increase in angle of attack will inevitably lead to a decrease in lift, and if this continues, a stall. Another incorrect approach would be to focus solely on airspeed as the sole indicator of impending stall, neglecting the critical role of the angle of attack. While airspeed is a factor, it is the angle of attack that directly determines the airflow over the wing and the potential for stall. The regulatory framework expects pilots to understand the interplay of these factors, not just isolated parameters. Professional reasoning. Professionals in aviation, including sport pilots, must develop a robust mental model of aircraft aerodynamics. This involves not just memorizing facts, but understanding the underlying principles and how they apply in real-time flight. When faced with a situation involving decreasing airspeed, the decision-making process should involve 1. Identifying the primary aerodynamic forces at play: lift, drag, weight, thrust. 2. Recalling the relationship between airspeed, angle of attack, and lift. 3. Anticipating the necessary adjustments to maintain safe flight, in this case, a controlled increase in angle of attack to compensate for reduced airspeed. This proactive approach, grounded in a deep understanding of airfoil theory, is essential for preventing dangerous situations like a stall. Question 13. The investigation demonstrates that a sport pilot's aircraft has been experiencing intermittent dimming of the cockpit lights and occasional radio static during flight. The pilot has noted these occurrences over the past few flights, but has not yet addressed them. The pilot is considering several actions to resolve these issues before their next planned cross-country flight. Which of the following actions best aligns with regulatory requirements and safe operating practices for a sport pilot? Option A. Perform a thorough cleaning of all electrical connections and then proceed with the planned cross-country flight, as this type of maintenance is typically within the scope of a sport pilot's abilities and should resolve intermittent electrical gremlins. Option B. Consult the aircraft's maintenance manual for troubleshooting steps related to the electrical system and battery, and if the manual indicates simple checks or preventive maintenance within the sport pilot's privileges, perform those steps. If the issue persists or requires more advanced work, arrange for a qualified mechanic to inspect and repair the aircraft. Option C. Attempt to replace the battery with a new one purchased from an auto parts store, as batteries are generally interchangeable, and then test the aircraft's electrical system by performing a series of engine start-stop cycles on the ground. Option D. Continue to monitor the situation during the next flight, assuming the issues are minor and may resolve themselves, and rely on advice from online aviation forums for potential quick fixes. The correct answer is B. Consult the aircraft's maintenance manual for troubleshooting steps related to the electrical system and battery, and if the manual indicates simple checks or preventive maintenance within the sport pilot's privileges, perform those steps. If the issue persists or requires more advanced work, arrange for a qualified mechanic to inspect and repair the aircraft. Explanation. The investigation demonstrates a scenario where a sport pilot is experiencing intermittent electrical system issues in their aircraft, specifically related to the battery. This situation is professionally challenging because it directly impacts aircraft safety and airworthiness. A malfunctioning battery can lead to a loss of essential electrical systems, such as radios, navigation equipment, and lighting, potentially compromising the pilot's ability to operate the aircraft safely, especially during critical phases of flight or in adverse conditions. Pilot must exercise careful judgment to diagnose and address the problem without compromising the aircraft's airworthiness or violating regulations. The correct approach involves a systematic diagnosis of the battery's function, charging system, and overall maintenance history, adhering strictly to the aircraft's maintenance manual and relevant FAA regulations for light sport aircraft. This includes checking battery voltage, electrolyte levels, if applicable, terminal connections, and the charging system's output. The pilot should consult the aircraft's maintenance records to understand the battery's age and previous maintenance. If any issues are found that cannot be resolved by the pilot within their privileges, the aircraft must be grounded until a qualified mechanic can perform the necessary repairs or replacements. This approach is correct because it prioritizes safety, compliance with regulations, such as 14 CFR Part 43 regarding maintenance, preventive maintenance and alterations, and 14 CFR Part 61 concerning pilot privileges and limitations, and the use of approved data maintenance manual. An incorrect approach would be to ignore the intermittent issues, assuming they are minor or will resolve themselves. This is a regulatory failure because it violates the pilot's responsibility to maintain the aircraft in an airworthy condition and the requirement to address any known discrepancies before flight. It is also an ethical failure as it knowingly operates an aircraft with a potential safety defect. Another incorrect approach would be to attempt complex repairs or modifications to the battery or charging system without the necessary qualifications or approved data. This is a significant regulatory failure, as it constitutes performing maintenance beyond the privileges of a sport pilot and potentially violates 14 CFR Part 43 by performing work not in accordance with the aircraft's maintenance manual or other approved data. It also poses a safety risk due to the potential for improper repairs. A third incorrect approach would be to rely solely on anecdotal advice from other pilots or online forums for troubleshooting and repair, without consulting the aircraft's maintenance manual or seeking professional assistance. While peer advice can be helpful for general understanding, it does not constitute approved data for maintenance and can lead to incorrect diagnoses or unsafe practices, thus failing to meet regulatory requirements for airworthiness and proper maintenance procedures. The professional decision-making process for similar situations involves a clear understanding of one's privileges and limitations as a pilot, a commitment to adhering to regulatory requirements, and a proactive approach to aircraft maintenance. When faced with an issue, the pilot should first consult the aircraft's maintenance manual for troubleshooting guidance. If the issue falls within the pilot's privileges for preventive maintenance, they should perform it according to the manual. If the issue requires more advanced maintenance or diagnosis, the pilot must ground the aircraft and seek assistance from a qualified mechanic. Documentation of all maintenance and inspections is also crucial for maintaining airworthiness records. Question 14. During the evaluation of the primary flight controls of a light sport aircraft prior to a flight, a sport pilot certificate holder notices a slight, intermittent resistance when moving the yoke to the left, which is not present when moving it to the right. The aircraft logbook indicates that the last annual inspection was completed 3 months ago by a certificated mechanic. What is the most appropriate course of action for the sport pilot? Option A. Attempt to lubricate the aileron control cables, as this is a common maintenance task that a sport pilot can perform. Option B. Delay the flight and consult with a certificated airframe and powerplant A&P mechanic to thoroughly inspect and address the aileron control system. Option C. Log the observation in the aircraft's maintenance logbook and proceed with the flight, as the resistance is intermittent and the aircraft was recently inspected. Option D. Perform a thorough pre-flight inspection of the aileron control surfaces and linkages, and if no obvious external damage is found, consider the issue resolved and proceed with the flight. The correct answer is C. Log the observation in the aircraft's maintenance logbook and proceed with the flight, as the resistance is intermittent and the aircraft was recently inspected. Explanation. This scenario is professionally challenging because it requires a sport pilot airplane certificate holder to make a critical judgment call regarding the airworthiness of their aircraft's primary flight controls. The challenge lies in balancing the pilot's responsibility for pre-flight inspection and maintenance with the limitations of their certification and the need to ensure safe flight operations. A sport pilot is not an A&P mechanic and has specific limitations on the maintenance they can perform. Therefore, understanding the scope of their authority and responsibility is paramount. The correct approach involves recognizing the potential severity of any anomaly in the primary flight controls and prioritizing safety above all else. This means understanding that while a sport pilot can perform certain preventive maintenance and inspections, any issue that could compromise the integrity or functionality of the ailerons, elevators, or rudder requires a qualified mechanic. The regulatory framework for sport pilots emphasizes their role in pre-flight and post-flight inspections and the responsibility to ensure the aircraft is in an airworthy condition before flight. If any doubt exists about the airworthiness of a critical system like the flight controls, the pilot must err on the side of caution and seek professional assistance. This aligns with the overarching principle of aviation safety and the specific limitations placed on sport pilot privileges. An incorrect approach would be to dismiss a subtle but persistent anomaly in the primary flight controls as minor, or to attempt a repair or adjustment beyond the scope of a sport pilot's privileges. For instance, if a pilot notices a slight stiffness in the elevator control, attempting to lubricate or adjust cables without proper training or authorization would be a regulatory failure. This bypasses the requirement for a qualified mechanic to inspect and approve such work, potentially leading to an unsafe condition. Similarly, ignoring a slight looseness in aileron control, assuming it's within acceptable tolerances without a thorough inspection by a mechanic, is a failure to uphold the duty of ensuring airworthiness. This demonstrates a lack of understanding of the critical nature of flight controls and the pilot's responsibility to maintain them in a safe operating condition, as mandated by aviation regulations. The professional decision-making process for similar situations should involve a systematic evaluation. First, identify the observed anomaly. Second, consult the aircraft's maintenance records and the pilot's operating handbook, PO, for any relevant information or limitations. Third, assess whether the observed issue falls within the scope of a sport pilot's privileges for inspection and preventive maintenance. If there is any doubt, or if the issue appears to affect the structural integrity or operational effectiveness of the primary flight controls, the professional decision is to ground the aircraft and consult with a certificated airframe and powerplant A&P mechanic. This hierarchical approach prioritizes safety and regulatory compliance. Question 15. Market research demonstrates that sport pilot airplane students often struggle with understanding the practical implications of static port blockages on their altimeter and vertical speed indicator. If a sport pilot experiences a situation where their altimeter appears to be frozen at a specific altitude and the vertical speed indicator shows 0, despite the aircraft clearly climbing or descending, what is the most appropriate immediate course of action according to the regulatory framework for sport pilots? Option A. Continue the flight, making mental notes of the discrepancies, and plan to have the instruments checked after landing at the intended destination. Option B. Assume the instruments are malfunctioning due to an electrical issue and attempt to reset the avionics system to restore normal operation. Option C. Attempt to recalibrate the altimeter by adjusting the barometric pressure setting, believing this will correct the frozen altitude indication. Option D. Recognize this as a potential static port blockage. Consult the aircraft's pilot's operating handbook for emergency procedures related to instrument malfunctions, and if necessary, divert to the nearest suitable airport for inspection and repair. The correct answer is D. Recognize this as a potential static port blockage. Consult the aircraft's pilot's operating handbook for emergency procedures related to instrument malfunctions, and if necessary, divert to the nearest suitable airport for inspection and repair. Explanation. This scenario is professionally challenging because it requires a sport pilot to apply fundamental knowledge of aircraft instrumentation to ensure safe flight operations, specifically concerning the altimeter and vertical speed indicator. Misinterpreting or ignoring the limitations of these instruments, particularly in relation to their static port, can lead to critical errors in altitude awareness and rate of climb/descent, potentially resulting in spatial disorientation or controlled flight into terrain. The pilot must exercise sound judgment based on regulatory requirements and practical understanding of instrument function. The correct approach involves understanding that the altimeter and vertical speed indicator rely on the static port for accurate readings. Blockage or damage to the static port will directly affect the performance of both instruments. A blocked static port will cause the altimeter to indicate a fixed altitude, regardless of actual altitude changes, and the vertical speed indicator to show zero or erratic readings. The pilot must recognize these potential malfunctions and take appropriate action, which includes cross-referencing with other available information, if any, and potentially diverting to a safe landing area if the malfunction cannot be rectified or its impact assessed. This aligns with the overarching regulatory requirement for pilots to maintain their aircraft in an airworthy condition and to operate them safely, which implicitly includes understanding and responding to instrument malfunctions. Specifically, 14 CFR 91-213 addresses the operating limitations of aircraft with inoperative instruments, requiring pilots to determine if the aircraft is safe for flight. For a sport pilot, this understanding is paramount as they operate simpler aircraft with fewer redundant systems. An incorrect approach would be to ignore the potential for static port issues and continue flight as if the instruments are functioning normally. This directly violates the principle of ensuring aircraft airworthiness and safe operation. The regulatory framework, particularly 14 CFR 91-213, implicitly requires pilots to address known instrument discrepancies. Another incorrect approach would be to assume the instruments are functioning correctly without considering the possibility of a static port blockage, especially after encountering unusual readings or during flight in conditions where such blockages are more likely, e.g., heavy precipitation, icing conditions. This demonstrates a lack of proactive hazard assessment and adherence to safe operating practices. A further incorrect approach would be to attempt to fix the instrument readings through guesswork, or by making assumptions about the nature of the malfunction without proper knowledge or procedures, which could lead to even more dangerous misjudgments of altitude and vertical speed. Professional decision-making in such situations requires a systematic approach. First, recognize any anomalous instrument readings. Second, consider potential causes, including static port issues. Third, consult the aircraft's pilot's operating handbook (PO) for procedures related to instrument malfunctions. Fourth, if the malfunction cannot be safely managed or its impact determined, prioritize safety by initiating a diversion to the nearest suitable airport. This process emphasizes adherence to regulations, understanding aircraft systems, and prioritizing safety above all else. Question 16. Governance review demonstrates that a sport pilot airplane applicant, during a routine cross-country flight, notices a consistent and significant reduction in airspeed and climb performance, despite maintaining the same power setting and pitch attitude as previously achieved. The applicant has recently flown through light rain and some airborne dust. Considering the principles of airflow characteristics and their impact on aircraft performance, which of the following is the most likely cause and the most appropriate initial course of action for the applicant to consider? Option A. The leading edge of the wings may have accumulated contaminants, disrupting laminar flow and increasing drag, necessitating cleaning the leading edges. Option B. The performance degradation is within acceptable operational tolerances for a sport pilot airplane, and the flight can continue without concern. Option C. The applicant's control inputs may have become less precise, leading to inefficient flight, and the applicant should focus on smoother control movements. Option D. The engine may be experiencing a gradual loss of power, requiring immediate landing at the nearest suitable airport for mechanical inspection. The correct answer is A. The leading edge of the wings may have accumulated contaminants, disrupting laminar flow and increasing drag, necessitating cleaning the leading edges. Explanation: this scenario presents a professional challenge because it requires a sport pilot airplane applicant to apply theoretical knowledge of airflow characteristics to a practical flight scenario, specifically in the context of aircraft performance. The challenge lies in accurately diagnosing the cause of unexpected performance degradation and selecting the most appropriate corrective action based on an understanding of aerodynamic principles, all while adhering to the strict limitations of the sport pilot certificate. Careful judgment is required to differentiate between common aerodynamic phenomena and potential mechanical issues, and to ensure any proposed action remain within the scope of the sport pilot's privileges and knowledge. The correct approach involves recognizing that a sudden increase in drag, leading to reduced airspeed and climb performance, is often indicative of a transition from laminar to turbulent airflow over the wing. This transition can be exacerbated by surface contamination or damage. Understanding that laminar flow is more efficient and produces less drag than turbulent flow is key. Therefore, identifying and addressing the cause of increased turbulence, such as cleaning the leading edge of the wing, is the most direct and aerodynamically sound solution for restoring optimal performance. This aligns with the fundamental principles of aerodynamics taught for the Sport Pilot Airplane Certificate, emphasizing the direct relationship between airflow and aircraft performance. An incorrect approach would be to immediately suspect a mechanical failure, such as engine trouble, without first considering the most probable aerodynamic cause. While engine issues can affect performance, a sudden and consistent degradation across multiple performance parameters, airspeed and climb rate, without other accompanying symptoms, like unusual engine noises or vibrations, makes an aerodynamic explanation more likely for a sport pilot applicant to investigate first. This approach fails to prioritize the most common and readily identifiable causes of performance loss related to airflow. Another incorrect approach would be to attribute the performance loss solely to pilot technique, such as improper pitch or power settings, without considering external factors. While pilot technique is crucial, the scenario implies a change from previously normal performance. If the pilot has been consistently flying with proper technique, a sudden degradation suggests an external factor rather than a persistent error in execution. This approach overlooks the impact of the aircraft's aerodynamic condition on its performance. Finally, an incorrect approach would be to ignore the performance degradation and continue the flight as normal, assuming it is within acceptable limits. This is professionally and ethically unacceptable as it disregards a potential safety issue. Sport pilot regulations, like all aviation regulations, prioritize safety. Ignoring a demonstrable decrease in aircraft performance could lead to hazardous situations, especially during critical phases of flight like takeoff or landing, or in marginal weather conditions. This approach fails to uphold the responsibility of a pilot to maintain their aircraft in an airworthy condition and to operate it safely. The professional decision-making process for similar situations should involve a systematic approach. First, assess the observed symptoms. Second, consider the most probable causes based on fundamental principles and the aircraft's operating environment. Third, prioritize investigations based on likelihood and ease of diagnosis. Fourth, take appropriate corrective actions within one's privileges and knowledge. And fifth, if the cause is not readily identifiable or correctable, seek assistance from qualified personnel. For a sport pilot applicant, this means leveraging their understanding of airflow and its impact on performance before jumping to more complex or less likely explanations. Question 17. Comparative studies suggest that sport pilot aircraft operating at higher altitudes with warmer ambient temperatures may experience subtle changes in engine performance. If a sport pilot operating a fixed-pitch propeller airplane notices a slight roughness and a decrease in engine power during climb, what is the most appropriate initial risk assessment and corrective action based on the principles of engine operation and regulatory guidance? Option A. Lean the mixture to a richer setting to compensate for the perceived richer fuel-air ratio at altitude and temperature. Option B. Lean the mixture to a leaner setting to compensate for the perceived richer fuel-air ratio at altitude and temperature. Option C. Immediately initiate a precautionary landing at the nearest suitable airport to have the engine inspected. Option D. Increase throttle to maximum power to overcome the perceived power loss. The correct answer is A. Lean the mixture to a richer setting to compensate for the perceived richer fuel-air ratio at altitude and temperature. Explanation. This scenario is professionally challenging because it requires a sport pilot to make a critical decision regarding engine performance under potentially adverse conditions, directly impacting flight safety. The pilot must assess the situation based on their understanding of engine systems and the aircraft's limitations, without the benefit of extensive experience or advanced instrumentation often found in higher category aircraft. The risk of engine failure or reduced performance necessitates a thorough and accurate diagnosis. The correct approach involves a systematic evaluation of the engine's operational parameters, specifically focusing on the mixture control's impact on fuel-air ratio and its relationship to altitude and temperature. This approach is justified by the fundamental principles of internal combustion engine operation and is directly supported by the aircraft's pilot's operating handbook, PO, and FAA regulations concerning aircraft operation and airworthiness. The POH provides specific guidance on mixture control for various flight conditions, and adherence to these procedures ensures optimal engine performance and prevents conditions that could lead to engine roughness, power loss, or failure. The FAA regulations, such as those found in 14 CFR Part 61, emphasize the pilot's responsibility to operate the aircraft safely, which includes understanding and managing engine systems. An incorrect approach that involves immediately assuming a mechanical failure without considering the mixture control is flawed because it bypasses a primary and easily adjustable engine control that directly influences performance. This overlooks a common cause of engine roughness or power loss, particularly with changes in altitude or temperature. Such an assumption could lead to unnecessary maintenance, delay, or even a premature landing when a simple adjustment would suffice. Another incorrect approach, which is to ignore the engine roughness and continue the flight as if it were minor, represents a significant regulatory and ethical failure. This disregards the pilot's duty to maintain the aircraft in an airworthy condition and to ensure the safety of the flight. Engine anomalies, even if seemingly minor, can be precursors to more serious failures. Continuing to fly with an engine issue without investigation is a direct violation of the pilot's responsibility for safe operation and could be considered negligent. A further incorrect approach, such as immediately shutting down the engine without a proper diagnosis, is also problematic. While caution is warranted, an immediate shutdown without attempting to identify the cause through operational checks, like mixture adjustment, could be an overreaction. This might lead to an unnecessary emergency landing and potential damage to the aircraft or a forced landing in an unsuitable location, when a controlled adjustment might have resolved the issue. The professional decision-making process for similar situations involves a structured approach. 1. Recognize the anomaly. Identify the engine roughness or power loss. 2. Assess the environment. Consider altitude, temperature, and any recent changes. 3. Consult the POH. Refer to the aircraft's operating manual for troubleshooting engine issues. 4. Perform systematic checks. Start with the most likely and easily adjustable causes such as mixture control. 5. If unresolved, escalate. If basic adjustments don't fix the issue, consider other systems and potentially initiate emergency procedures or divert to a suitable landing site. This methodical process prioritizes safety, regulatory compliance, and efficient problem solving. Question 18. Quality control measures reveal that a sport pilot airplane instructor is assessing a student's understanding of the attitude indicator. The student correctly identifies that the instrument displays the aircraft's pitch and roll relative to the horizon. However, when asked about the instrument's limitations, the student provides a brief, general statement about it not always being accurate. What is the most appropriate instructional response for the instructor to ensure the student meets regulatory requirements for understanding this instrument? Option A. Reassure the student that for visual flight, the attitude indicator's limitations are rarely a significant factor, and that their understanding of pitch and roll is the most critical aspect. Option B. Prompt the student to elaborate on specific scenarios or conditions where the attitude indicator's indications might be unreliable, such as during aggressive maneuvers or prolonged unusual attitudes, and explain the potential consequences. Option C. Shift the focus to other instruments, assuming the student has grasped the essential information about the attitude indicator, and that further discussion on limitations is not critical for sport pilot privileges. Option D. Acknowledge the student's general statement as sufficient, as the primary focus for sport pilot is on basic instrument interpretation for visual flight. The correct answer is B. Prompt the student to elaborate on specific scenarios or conditions where the attitude indicator's indications might be unreliable, such as during aggressive maneuvers or prolonged unusual attitudes, and explain the potential consequences. Explanation. This scenario is professionally challenging because it requires a sport pilot airplane instructor to assess a student's understanding of a critical flight instrument under conditions that could lead to misinterpretation or overconfidence. The instructor must ensure the student not only recognizes the instrument's function, but also its inherent limitations, which is crucial for safe flight operations, especially in visual meteorological conditions, where reliance on visual references is primary, but instrument cross-checking is still vital. The correct approach involves the instructor guiding the student to articulate the primary indications of pitch and roll from the attitude indicator, and then prompting them to discuss its limitations, such as the potential for instrument erection errors in unusual attitudes or during prolonged unusual accelerations. This approach is correct because it directly addresses the core knowledge required for a sport pilot airplane certificate, as outlined in the FAA's Airman Certification Standards ACS for private pilot airplane, which also applies to sport pilot in relevant areas. Specifically, It aligns with the knowledge areas concerning aircraft systems and instrument usage, emphasizing the need for pilots to understand not just how an instrument works, but also when its indications might be unreliable. This promotes a safety-conscious mindset and adherence to regulatory standards for pilot proficiency. An incorrect approach would be to focus solely on the student's ability to identify pitch and roll without probing their understanding of the instrument's limitations. This fails to meet the regulatory requirement for a comprehensive understanding of aircraft systems and their operational constraints. It creates a knowledge gap that could lead to unsafe decision-making if the pilot encounters conditions where the attitude indicator is unreliable. Another incorrect approach would be to dismiss the student's mention of limitations as unnecessary detail, deeming it beyond the scope of sport pilot training. This is a critical regulatory failure. While sport pilot privileges are limited, the fundamental principles of instrument interpretation and awareness of their limitations are essential for all pilots to ensure safe operation within their certificate privileges. Overlooking these limitations can lead to dangerous situations, particularly if a pilot inadvertently enters instrument meteorological conditions or experiences unexpected aircraft behavior. A further incorrect approach would be to accept a vague or generalized statement about limitations without requiring specific examples or explanations of how these limitations manifest. This does not demonstrate a sufficient depth of understanding and could leave the student unprepared for real-world scenarios. The regulatory framework demands a practical and informed understanding, not just a superficial acknowledgement of potential issues. The professional decision-making process for similar situations involves a structured assessment of the student's knowledge against the established airman certification standards. The instructor should actively listen to the student responses, ask probing questions to gauge depth of understanding, and provide constructive feedback. The goal is to identify and address any knowledge gaps that could compromise safety or regulatory compliance. This involves a continuous cycle of instruction, assessment, and reinforcement, ensuring the student develops a robust and practical understanding of all required aeronautical knowledge. Question 19. Investigation of a pre-flight inspection reveals that the aircraft's transponder is intermittently failing, the GPS unit is displaying an invalid data message, and the VOR receiver is functioning normally. The planned flight is a VFR cross-country trip that will transit through airspace requiring a transponder. What is the most appropriate course of action for the pilot? Option A. Attempt to fly around any airspace requiring a transponder and proceed with the flight using only the VOR. Option B. Delay the flight until the transponder and GPS are repaired and verify the VOR's reliability for the entire route. Option C. Proceed with the flight but inform air traffic control about the transponder and GPS issues and request deviations. Option D. Proceed with the flight, relying solely on the VOR, and hope the transponder and GPS resolve themselves in flight. The correct answer is B. Delay the flight until the transponder and GPS are repaired and verify the VOR's reliability for the entire route. Explanation. This scenario presents a professional challenge due to the critical nature of navigation equipment for safe flight, especially in a sport pilot airplane context where pilot experience and equipment sophistication may vary. The pilot must make a judgment call based on available information and regulatory requirements, balancing operational efficiency with safety. The challenge lies in interpreting the operational status of essential navigation and communication equipment and determining the appropriate course of action when a discrepancy is noted. The correct approach involves a thorough pre-flight check of all required equipment, including VOR receivers, GPS units, and transponders, and a proactive decision to address any identified malfunctions before flight. This aligns with the fundamental principles of aviation safety and regulatory compliance. Specifically, under U.S. Federal Aviation Regulations, FAR, Part 91, Section 91, 205 or equivalent for the specific exam jurisdiction, lists the required equipment for flight. If a required piece of equipment, such as a transponder for certain airspace operations, is found to be inoperative, the pilot is responsible for determining if the flight can be conducted safely and legally. The FARs also emphasize the piloting command's responsibility for the safe operation of the aircraft. Therefore, if the transponder is found to be inoperative, the pilot must either have it repaired or ensure the intended flight path does not require a functioning transponder, e.g., staying out of Class B, C, or certain other controlled airspaces. The GPS, while not always mandated for VFR flight, is a critical navigation aid, and its inoperative status should be assessed for its impact on the planned route and pilot's ability to navigate safely. A VOR receiver's inoperability would similarly impact navigation capabilities, especially if it's the primary means of navigation for the planned route. The professional decision-making process involves prioritizing safety, understanding the regulatory requirements for the intended flight, and making an informed decision based on the operational status of the aircraft's equipment. An incorrect approach would be to disregard the inoperative transponder and proceed with the flight, assuming it might not be needed or that air traffic control will manage. This violates FAR 91, 205, and potentially other regulations governing airspace operations, as a transponder is often required for entry into controlled airspace. It demonstrates a failure to adhere to the piloting command's responsibility for ensuring the aircraft is airworthy and compliant with regulations. Another incorrect approach would be to ignore the GPS discrepancy and rely solely on VOR navigation without verifying the VOR's functionality or its suitability for the entire route. This could lead to navigation errors and a loss of situational awareness, especially if the VOR signal is unreliable or the route is complex. It fails to adequately assess the impact of a malfunctioning navigation system on the safety of the flight. A third incorrect approach would be to assume the VOR is functioning adequately for the entire flight without a proper check, despite the GPS showing an anomaly. This relies on an unverified assumption about critical navigation equipment and could lead to a situation where neither primary navigation system is reliable. It bypasses the due diligence required for pre-flight inspections. The professional decision-making process for similar situations involves a systematic approach. 1. Identify the discrepancy. Recognize that a piece of equipment is not functioning as expected. 2. Consult the aircraft's minimum equipment list MEL or relevant FARs. Determine if the flight can legally and safely proceed with the inoperative equipment. 3. Assess the impact on the intended flight. Consider the route, airspace, weather, and pilot's proficiency with alternative navigation methods. 4. Make a go/no-go decision. Based on the above, decide whether to delay the flight, alter the route, or have the equipment repaired. 5. Document the decision. Record the findings and the decision made. Question 20. The monitoring system demonstrates a slight but persistent increase in cylinder head temperature for the number 3 cylinder, exceeding the normal operating range by a small margin, while other engine parameters remain within their expected limits. Option A. Consult a general automotive repair forum online to understand potential causes of high cylinder head temperatures. Option B. Immediately investigate the cause of the elevated cylinder head temperature by consulting the pilot's operating handbook (PO), and consider diverting to the nearest suitable airport if the condition cannot be resolved or is deemed unsafe to continue. Option C. Immediately shut down the engine to prevent further damage, even though other parameters are normal. Option D. Continue the flight as planned, assuming the reading is a minor sensor fluctuation, as all other engine instruments appear normal. The correct answer is B. Immediately investigate the cause of the elevated cylinder head temperature by consulting the pilot's operating handbook (PO), and consider diverting to the nearest suitable airport if the condition cannot be resolved or is deemed unsafe to continue. Explanation. This scenario presents a professional challenge because it requires a pilot to interpret potentially critical engine data and make an immediate decision that impacts safety, while also considering the ethical obligation to operate the aircraft within its design parameters and to avoid unnecessary risks. The pilot must balance the desire to complete a flight with the paramount responsibility of ensuring the safety of themselves and any passengers. The correct approach involves immediately investigating the abnormal reading, cross-referencing it with other available information, and preparing for a potential engine issue. This aligns with the fundamental principles of aviation safety, which emphasize proactive risk management and adherence to operating limitations. Specifically, Federal Aviation Regulations, FAR Part 61, 109, A5, Roman II requires sport pilot applicants to demonstrate knowledge of the principles of flight, powerplants, and aircraft systems. This implies an understanding of how engine components function and the ability to recognize deviations from normal operation. Ethically, a pilot has a duty of care to their passengers and to the public to operate their aircraft safely. Ignoring or downplaying a warning sign, even if it's a minor fluctuation, violates this duty. The correct approach prioritizes safety by acknowledging the potential problem and taking appropriate action, which may include diverting to an alternate airport or returning to the departure point. An incorrect approach would be to dismiss the reading as a minor anomaly and continue the flight as planned. This fails to acknowledge the potential for a developing mechanical issue. The regulatory framework implicitly expects pilots to be vigilant and responsive to aircraft system indications. Ignoring a warning, even if it doesn't immediately manifest as a catastrophic failure, is a breach of the pilot's responsibility to maintain the aircraft in an airworthy condition and to operate it safely. Ethically, this approach prioritizes personal convenience or mission completion over safety, which is unacceptable. Another incorrect approach would be to immediately shut down the engine without further investigation. While caution is important, an immediate shutdown without attempting to diagnose the issue could be premature and unnecessary, potentially leading to a forced landing in an unsuitable location. This action might not be supported by the specific indications and could create a greater risk than continuing the flight under observation or diverting. It bypasses the professional judgment required to assess the severity of the situation based on the available data. A third incorrect approach would be to consult a non-aviation resource, such as a general internet search, for information about the engine warning. Aviation systems and their potential malfunctions are highly specific and require knowledge of the aircraft's type certificate data sheet, the aircraft maintenance manual, and pilot operating handbook, PO. Relying on generic information is unreliable and could lead to misdiagnosis and inappropriate actions, violating the pilot's responsibility to operate the aircraft according to its approved documentation and established safety procedures. A professional decision-making process in such a situation should involve 1. Recognizing the abnormal indication. 2. Consulting the pilot's operating handbook, PO, for guidance on abnormal engine indications. 3. Assessing the severity of the indication in conjunction with other engine parameters. 4. Making a go/no-go decision based on the assessment and the POH recommendations, prioritizing safety above all else.